So in this video, it looks like we're going to be practicing completing the square, okay? So let's begin right away. I'll explain how to complete the square via the examples on this page probably, okay? I also have a short on where it comes from so you can watch that as well. Not short, it's a video, I believe, a long form video. So you can go watch that if you're interested in why we use this technique and where it comes from. It actually comes from the perfect square formula, if you remember from the last video. We worked on factoring complete squares. Okay, anyway, if x squared minus 10x equals 75 and x is less than 0, what is the value of x plus 5? So, how can we do this? Well, actually, we don't even need to complete the square in this one, it looks like, because I feel like we can factor this. So let's try it. We don't even need to complete the square. You could, if you want to, but I prefer factoring if it's doable. Okay, so that just goes to show that even in completing the square section, you can use other techniques if you think it's faster. Okay, so if I factor this, it'll be x minus, what is this? 15 and 5 would work, right? My 15, x plus 5 equals 0. So our solutions are x is 15 and minus 5. They tell us x is less than 0, so we're going to take this one. And by the way, this is not the answer, so don't be fooled here. They're asking for x plus 5. So minus 5 plus 5, the answer is D. It's 0. It's not negative 5. That's not what the question is asking, so be careful. Okay, x squared minus kx is 20. X minus k over 2 equals 6. Which of the following is a possible value of x? Okay, so this looks like maybe we have to complete the square because this k over 2 looks familiar to me. If you remember, in completing the square, you have to take the, if it's in standard form, ax squared plus bx plus c, yet a has to be 1, which it is in this case. You take b over 2, and then you square it. If that sounds familiar. And this looks kind of like that. So probably completing the square is the best way to solve this problem. So, let me see. If I want to complete the square, actually, do I need to complete the square? Which of the following is the possible value of x? See, I'm thinking now, should I complete the square? I feel like that might be a lot of work, but okay, let's try it. X squared minus kx plus minus k over 2 squared equals 20 plus minus k over 2 squared. Whatever you do to one side of the equation, you gotta do to the other. This is the technique to complete the square, but you can't just add this term. It doesn't make it equal anymore. So you gotta add it to the other side of the equation or you subtract it back right away. Okay, so this would factor into x minus k over 2 squared, which is equal to 20 plus, that would be, should I say, k squared over 4. Let's just write that. Okay. They tell us x minus k over 2 is 6, so this is 6 squared, which is 36, equals 20 plus k squared over 4. Okay, now if I subtract 20 on both sides, that's 16 is 16, right? 16 is k squared over 4, so 4 times 16 is k squared. So k is plus or minus square root of 4 times 16, which is plus or minus 2 times 4, which is 8. K is plus or minus 8, okay? Therefore, if k doesn't tell us which one, so we got to try both to see if we get a matching answer. If k is 8 over here, we could probably plug into either, but I don't want to square stuff, so let me plug into here, or square root or factor or whatever in this one. So let's plug into here. This is a linear equation. If k is 8, then x is 6 plus 8 over 2, which is 6 plus 4, which is 10. That's not here, but what if k is minus 8, so this would be x plus 4 is 6, so x is 2. That's the answer. Yep, okay. So this is one possible value of x. So you could solve it like this. Exactly, I completed the square. Actually, now that I looked at my solution, that I solved this one before, it looks like, I did it a totally different way. So let me show you what I did. So a different way to do this without completing the square looks like is x minus k over 2 equals 6, right? So we can write this as k is 6 minus x times minus 2, which is 2x minus 12. Okay? K is 2x minus 12. I can put that into here. So let me write it up here. X squared minus 2x minus 12. And another x equals 20. And then we can solve for x from here. This is x squared minus 2x squared minus 12x equals 20, which is x squared minus 2x squared plus 12x equals 20. Okay, so this would be 0 is equal to x squared minus 12x plus 20. Okay, and from here we can factor into x minus 10, x minus 2. Remember earlier I said that x, when I was plugging these values of k into here, that x was 10 and x is 2. Well, 10, again, it's not here. 2 is the solution. So, answer is A, as expected. You can see I didn't have to complete the square here, actually. So there's a different way to do it. Okay? So, take your pick. Honestly, if I didn't know that this section was about completing the square, I probably wouldn't do it like this. I'd probably do it exactly how I did it in the red over here. Okay. Which of the following is an equivalent form of the equation shown above, from which the equation could be solved by completing the square? Okay, so again, to complete the square, you have to take the, first of all, the a, if this is standard form, needs to be 1, which it is. The b, if it's standard form, you take that b, divide it by 2, and you square it. So it'll be x squared minus k over 3x plus minus k over 3 over 2, so k over 6 squared equals 5 plus, you add the same thing on the other side of the equation as I said earlier. Okay, so let's see. So it should be, if we simplify this by squaring it, it should be k squared over 36. This one looks like the only one, right? So the answer should be C. Don't even have to simplify. In the interest of time on the SAT exam, you should just stop here and start looking at the choices. Okay? Number 4. In the quadratic equation above, k and r are constants. I guess there's a typo there. What are the solutions for x? Okay? So this you can probably solve with quadratic formula if you really wanted to. Or you can complete square. So, honestly, I feel like quadratic formula is easier here. So, let's rewrite this as x squared minus rx minus k squared over 4 equals 0. Okay? So, let's use the quadratic formula. X is opposite of b, so r plus minus square root of r squared minus 4 times 1 times k squared over 4, right, over 2a. A is 1. Oh, you will write that. Okay? Which is r plus or minus square root of r squared. This would be k squared over 16, but there's a 4 there, so k squared over 4. Actually, this is not k over 4 squared, it's just k squared over 4. So these cancel, so it would just be minus k squared. Is it minus or is it plus? It should be a minus here, right? Yeah, so it should be a plus over 2. Okay, And that's it should be this one. I'm like, which one? It's not this. It's this one. Isn't it D? Let me check. Yeah, it's a D. Okay, so quadratic formula looks like it was easier than completing the square. Again, you could do it via completing the square. I'm not going to do it here in the interest of time, but you could have. Maybe you should try it and see that you get the same answer. Maybe that's good practice. So I'll let you try that on your own. But on test time, I would think to use quadratic formula, honestly. Okay, if x minus 7, x minus s is x squared minus rx plus 14. For all values of x, what is the value of r plus s? Okay, well, this should be quite easy to get s. If we expand this out, the constant value would be plus 7s. Plus 7s has to equal to 14, so s is equal to 2, okay? This r, okay, so if s is 2, then our r should be minus 7x minus 2x, which is minus 9x, so r is 9, so r plus s, 11. Okay, and remember for, at least back then, for the free response questions in the SAT exam, they have to be positive, so at the very least, I got a positive answer, and this is the answer though. Okay, last one. If x squared minus 3 over 2x plus c is x minus k squared, what is the value of c? Okay, this is completing the square over here, it looks like. We want a perfect square from expanded form. How can we make that happen? So, if the c is exactly the thing we do when we complete the square, minus 3 over 2 and square it. What is that? That's minus 3 over 4, and we square it, which is 9 over 16. That's the answer, as simple as that. If c is 9 over 16, then we get a complete square. Perfect square. Okay, if you're not convinced, try it and try factoring it. And then you'll see that you'll get it. All right, that's it for this video. I really did not use completing the square that much. Only here I had to use it a little bit, not really even completely. Over here, you had to use it to get a matching answer. I didn't even have to use it here. I didn't have to use it here. I didn't not even use it here. So really, as you can see, completing the square is useful sometimes, but at least for me, I prefer other techniques. For me personally, I'm more comfortable using those techniques because I've used them more, and therefore I'm faster at them. So I would prefer, me personally, again, I prefer like quadratic formula and basic factoring and all that. But anyway, as I said in some problem, maybe it's good practice for you to try using different methods. Like this one, actually try using completing the square. For this one, you can try both methods, as I did here, and you should get the same answer. This one, you can even try completing the square, and you should get the same answer as well. All right, so good. Yeah, so basically, if you're not comfortable completing the square, get some more practice in it for sure, and you can get practice in by doing these problems in multiple ways. All right, enough rambling. Please like and subscribe as always if you found this helpful, and please look out for the next practice problem set.